The purpose of this video is to teach you how to simplify rational expressions. To do that, we need to talk about what counts as a rational expression. So by definition, a rational expression is a quotient of two polynomials. Quotient means division, so basically it's a rational expression if you have a polynomial divided by a polynomial. The easiest type to work with first is a monomial divided by a monomial. So that's the example that I have right here. The directions say to simplify and then to state the domain restrictions. That's basically any variable values for which the expression is undefined. So it's going to be undefined if we have a 0 in the denominator. We're not allowed to divide by 0. That's like the one rule in math that you can't break. We can't divide by 0. So when it says state domain restrictions, they're looking for all of the numbers that x, or in this case x and y, are not allowed to be, because you would end up with a 0 in the denominator. So the first thing we're going to do is to just simplify the rational expression. So we're going to simplify the like parts. So 3 and 12 are both numbers, x to the 7th and x to the 4th are both x's, y to the 3rd and y to the 8th are both y's. So for the 3 and the 12, we're looking for a number that goes into each of them. Since 3 goes into both of these numbers evenly, 3 goes into 3 one time, it goes into 12 4 times. Next we're going to look at the x's. There are 7 x's on top. Remember, x to the 7th is x times x times x times x until you have 7 of them. So there's 7 x's on top, 4 x's on bottom. Since there are less x's on the bottom, I can get rid of all 4 of them as long as I get rid of 4 from the top. So I have 7. I'm getting rid of 4 of them. That means I still have 3 x's on the top. For the y's, I have 3 on top, 8 on bottom. So I'm going to get rid of all 3 y's from the top, but to do that I have to get rid of 3 y's from the bottom, which would leave me with 5 y's. So my simplified expression is 1x to the 3rd over 4y to the 5th. Since there is 1x to the 3rd, we don't need to write the 1. So I have x to the 3rd over 4y to the 5th. So this is how you would write your simplified rational expression. And now you have to state your domain restrictions. So what is it that x and y are not allowed to be, or else they would provide you a 0 in the denominator? So when you're doing that, you do not want to do that from your simplified form. Because here it looks like x could be any number. But when you're starting with your original, if x were 0, 0 to the 4th power is 0, and 12 times 0 times anything else is still going to be 0. So you need to look at your original when you're trying to come up with your domain restrictions. So in this case, x is not allowed to be 0, and y, for the same reason, is not allowed to be 0. So this is your final answer. You have your simplified rational expression and your domain restrictions. So this was a monomial divided by a monomial. Next we're going to look at a trinomial divided by a trinomial. Anytime it's not a monomial, you want to factor everything that can factor. So I have x squared minus 2x minus 3. I'm going to factor this. This will factor into x minus 3 times x plus 1. It is so important that you take the time to make sure that these are the correct factors. So I want to expand it out or FOIL it out or distribute whatever you want to use in your mind to make sure that these are the correct factors. So when I do x times x, I get x squared. I have a positive x minus 3x, that's negative 2x. Negative 3 times 1 is negative 3. So make sure that you are checking your factors. If you don't factor it correctly, you will not get these correct. So now I need to factor the denominator. This one is going to factor into x plus 4 and x plus 1. If you are struggling with factoring, you definitely need to come in and get help on this. You will not survive this chapter if you cannot factor. So my next step after I've factored everything is I want to cancel out all of the factors that are the same on the top and the bottom. So on the top I have an x plus 1, That's going to cancel out with the x plus 1 on the bottom. So now what I'm left with is x minus 3 over x plus 4. So my simplified rational expression is x minus 3 over x plus 4. Now I have to state my domain restrictions. Here I only have one variable, so I'm interested in what x is not allowed to be. The easiest place to figure out your domain restrictions is in your factored form. Remember, we want the original. We don't want the final simplified answer. So looking at the original, in my factored form, if you are trying to figure out what x is not allowed to be, set each one of your factors equal to 0 and solve for x, and that's what your domain restrictions are going to be. So here I would subtract 4, and I would get that x equals negative 4. Here I would subtract 1 and get that x equals negative 1. That means that x cannot be negative 4 and x cannot be negative 1, or else I will end up with a 0 in the denominator. So my domain restrictions are that x is not equal to negative 4 or negative 1. Here you're just making a list of all of the numbers that x is not allowed to be. So now I have a binomial divided by a trinomial. The rules are still the same. I'm going to factor everything that can factor. So on the top there's no GCF, so I cannot factor this in any way. So now I'm going to move to factoring the denominator. This one, if you're struggling to figure out what to factor this as, I have a factor in the top. I have 3x plus 4. If you're completely stuck, you might think about trying 3x plus 4. I know this is going to factor like this. To get something times something to equal 3x squared, I know I have to have a 3x and an x. Here, to get a 4, I have to have a 1 and a 4. I know one of them has to be positive, one of them has to be negative. If you're stuck, try the factor that's on top. It's not always going to work out. It's possible that these are already as simplified as they can be. So if you're stuck, just try one of the factors from the top. So 3x plus 4 would be something that would allow me to cancel out. If I need to end up with a negative 4, and I currently have a positive 4, then I need to multiply that by negative 1. Again, especially if you're just trying factors from the top, make sure it works. 3x times x is 3x squared. I have a negative 3x and a positive 4x, so that would be positive 1x, and 4 times negative 1 is negative 4. So in this case, the factor from the top did in fact work with one of the factors on the bottom. So now I can cancel out this factor. When you cancel everything out of the top, it's not a 0 on top, it's a 1. So when everything cancels out, make sure you're still putting a 1 in its place. So my final simplified answer is going to be 1 over x minus 1. And now I need to state my domain restrictions. What is x not allowed to be equal to? So I'm looking at the original, and I'm looking at the factored form. So from this factor, x is not allowed to be equal to 1. On this one, if I set it equal to 0, I'd subtract 4 and then divide by 3. So x cannot be negative 4/3. And I want you to just leave it as a fraction. So here's my final answer. I have 1 over x minus 1, and x is not allowed to be positive 1 or negative 4/3. So we're going to try 2 more examples, and then you should be able to do your homework based on going through these examples. So now we're going to factor everything. So I need to start by factoring the top. The top is going to factor into 3x plus 2 and 2x plus 1. The denominator, again, if you're stuck, maybe see if it will work out to be one of these factors. So when I'm factoring this and I have 6x squared, there's 2 ways to get that. I can have 6x times x, or I can have 3x and 2x. The only way that something's going to cancel out is if I have the 3x and the 2x. So there's a really good chance, it's not guaranteed, that I'm going to actually end up using 3x and 2x. So as I'm going through this, I'm going to try, this can either be a 1 and a 6 or a 6 and a 1. It can be a 2 and a 3 or 3 and a 2, and I also need to play with my signs. So this one, it turns out, is 3x plus 2 and 2x minus 3. Remember to check. So this is 6x squared. Negative 9x plus 4x is negative 5x, and 2 times negative 3 is negative 6. So now I'm looking for my factors that cancel out. I have a 3x plus 2 on the top and on the bottom. So my final simplified answer is 2x plus 1 divided by 2x minus 3. Now we're looking for our domain restrictions, what x is not allowed to be equal to. So here I would add 3, then divide by 2, so that would be a positive 3/2. And then on this one I would subtract 2 and then divide by 3, so that would be a negative 2/3. So here's my simplified rational expression. Here are my domain restrictions. Alright, final example. This one is not currently written in standard form. Some people like to go ahead and put it in standard form first. For me, I'm going to go ahead and factor the denominator and see what kind of factors I'm possibly looking for that would cancel out. So when I factor the denominator, this one factors into x minus 2 and x plus 1. So if I check it, x times x is x squared. X minus 2x is negative x. Negative 2 times 1 is negative 2. So now I know I need to have either an x minus 2 or an x plus 1. I'm going to start with my GCF. If I factor out an x, then I have 2 minus x. It's not exactly the same. If I were to rewrite this, that would be x and then negative x plus 2. Still not, sorry, negative x plus 2. Some of you like to just change places. The negative goes with the x. This 2 is positive, so it has to be negative x plus 2. That's still not an exact match, so now I'm going to factor out a negative 1. So this would make this negative x, and when I factor out a negative 1, this x becomes positive, the 2 becomes negative. So now I have negative x times x minus 2 on top, and on the bottom I have x minus 2 and x plus 1. So my x minus 2's will cancel out. On the top I'm left with negative x. On the bottom I have x plus 1. My domain restrictions are going to be that x here cannot be negative 1, and on this one x cannot be positive 2. So going through these 5 examples was hopefully enough for you to be able to do the homework that is posted on the right.